Today's case study is inside the Hour of Code with Star Wars. My name is Brendan Reville, and I'm a software engineer with Code.org, which is a nonprofit based in Seattle. Has anybody heard of Code.org before? Oh, look, this is amazing. Has anybody done the Hour of Code before? Fantastic. So I was the lead engineer on the Star Wars tutorial that we shipped last year, and I'm going to show it. Some of you would have seen this before, but talk about some of the decisions we made along the way and talk about what it took to deliver this tutorial. First, a brief word about Code.org. We're a 3-year-old nonprofit organization. Our mission is very simple. It's that every student in every school should have the opportunity to learn computer science. We've got a lot of traction so far, along with a lot of excellent partner organizations, but there's still a lot of work left to do. What does Code.org do? Well, we're famous for the Hour of Code. It happens every December. We've done 3 hours of code so far, and it's a worldwide, a global event in which a lot of students try programming for the first time with some little bite-sized 1-hour-long tutorials. But actually, the more important stuff we do, we're not as famous for. Probably the most important thing we do is that we actually build an entire K through 12 curriculum of computer science, and we make it available free and open source, and it has all the supports teachers need, interactive tutorials for students, and we really are building an entire roadmap that we want everybody to be able to use if they want. We also train teachers, super important. Having all the curriculum in the world doesn't matter if you don't have teachers who also feel really good about teaching this material, and so we also partner with school districts and work through affiliates to actually train teachers. Finally, we do state and federal advocacy to make sure that computer science counts in every state and has the funding that it needs. The Hour of Code is a global event. Every year it generates an insane amount of internet traffic, starting at 6 a.m. in Seattle, which is 9 a.m. on the East Coast. We see this huge spike begin with the East Coast and then spreads across the whole country, but it's really global. This is from hourofcode.com, and last year, even before it began, we had 198,000 events around the world. These are real-world events in real classrooms and real community centers around the world. So you can imagine there's a lot of excitement and a lot of pressure on us and our partners to build great tutorials every year. This photo montage attempts to capture some of the excitement of students working on all different devices, working through their tutorials, sometimes having mentors helping them, and then printing their little certificates at the end of their hour. Let's go a little deeper into the Star Wars tutorial. I want to note we actually built a really great Minecraft tutorial with Microsoft as well. But today we're talking about the Star Wars tutorial. We built 2 versions of the same tutorial. The one I'll talk about mainly is the block one. We use we use Blockly, which is very similar to Scratch. It's block-based programming. A big reason we choose to do this for our younger students is because we don't want them having to battle syntax or typing errors. We want them to focus on building programs and getting the thrill of making a program. And so we do blocks. However, we did for older students this year build a version that works with typed JavaScript, and the students can actually flip back and forth between blocks and JavaScript, and I'll talk about that at the end. If you haven't seen one of our tutorials before, here's just a little glance at the user experience, and I'll point out a few things that happen on the screen. First, we have instructions, very important. For the Star Wars tutorial, we wanted our female protagonists, Rey and Princess Leia, to talk directly to the student. Then we gave some extra instructions, and you can see we annotated these instructions with little icons so that you actually know what a mouse droid looks like, for example. We also pop up the dialog box at the beginning of the tutorial with the instructions as well. We have the main play space area where the game actually takes place. So once the student writes the code for their game, then this is where the game plays out. We have a control area to start and stop and restart the game, and also directional arrows, because in this tutorial the student is actually steering a character around on the screen, and once they're on a touch device we need to provide this interface. We have our palette of blocks, and what you'll see is that in the early levels we start with a very small palette, but as you work through the level progression, more and more blocks get added, and we put a lot of thought into getting that just right. Then there is the workspace where a student drags these blocks in and actually constructs their program. In this case, we're doing event-driven programming, which is great for real-time games. So we have one event when the program begins running, and then when you get a mouse droid, we have another event that's triggered and blocks take place. Now, there's one thing up the top here that maybe you've seen before, maybe not, but it actually has turned out to be really important for us, and we call them our dots internally. It's our level progress. And we've found that when you're in a classroom and you have students all working through one of these progressions, it's really handy to have these dots at the top because as you walk around the room, at a glance, you can tell which students have skipped levels, which students are ahead, which ones are behind. Then you can start pairing up students who maybe find one who's ahead and one who's behind, pair them up to help each other. So these dots have turned out to be very useful in a whole bunch of scenarios. I've got a quick video, and it might actually have some sound, of one of our early levels in our tutorial. In this case, we started the tutorial with 6 levels of just you providing directions to BB-8 to steer around a screen. And we start very simple, but we ramp up the complexity. We'll see if this works. Well, there's meant to be some Star Wars music playing, but not sure what happened there. Anyway, you'll see we constructed a very simple program, just move right twice, move down twice, and that's all it took for the student to finish this first level. And we encourage experimentation and failing. You know, if they get something wrong and he walks the wrong way, that's fine. We'll just, the second time round, the student can adjust their program and make things work the second time. Here's a level, this is a few levels on. This is level 6 in our 15-level tutorial. And if you can just imagine working through this problem yourself, we've made things a lot more complicated. Now BB-8 has to go down and collect a piece of scrap metal and then backtrack and go back up and move around. And we have this danger of these bandit characters standing nearby. And what we found, what we really focus on in these tutorials is making sure that we ramp the difficulty so that students, you know, they're always making progress. They might struggle for a little bit on a few levels, but we never want them to feel like they have to give up. And so we've really crafted our levels so we keep them, I guess, in that flow zone from the previous speaker, where we're always letting students just get a little better every time, challenged but not too challenged. Before we proceed with the rest of some of the levels from the tutorial, I thought I'd take a detour and talk about the design goals that we had for this work. It took about 6 months to build this tutorial, beginning to end, in partnership with Disney and Lucasfilm. But first, we had to think about our design goals. So with all of our Hour of Code tutorials, it's going to be, most students, it will be their first ever coding experience. So we have to think the student has never coded before, they don't really understand even the concept of coding, but we want them to get by the end to actually understanding it and having a whole lot of fun and making something. Like I said, it has to fit into 1 hour, so we have to actually make sure we build a right-sized tutorial. It can be a bit less than an hour because classrooms have some overhead time, but roughly that's our rule of thumb. A lot of environments like Scratch are kind of a sandbox where the students are given every block at once. For us, it's important to build this level progression so that we can structure the students' progress. And it's also great for classrooms where teachers are maybe new to programming themselves because they know that we can look after the student and progress them through that level. Broad appeal is very important. Obviously, it was super exciting that we had Star Wars, and even more exciting when we found we had assets from the new movie that came out last year, like BB-8. What else is in? But more broad appeal is more than just the brand. Broad appeal means that we don't have violence, we don't have weapons, that we have great female role model protagonists, and that we don't do anything too scary, and we don't build games that are too tricky and twitch, you know, too difficult to play. Broad appeal means that we give everybody a great experience, and our mission is very much about diversity, and especially women and minorities, girls and minorities. We want to make sure we build a very broad appeal experience. For us, it's also important that the student builds a shareable game. So in the final level, they build their own game. They can post it to Facebook, they can send a link to their parents, they can save it for looking at later. So it's very important to us for the student to build a shareable game. Finally, broad compatibility, and especially when you go into schools, all of a sudden you're faced with very old computers, old operating systems, old web browsers, very obscure devices that schools have. And so we spend a lot of time not just working on the latest and greatest computers, but working on a really broad array of devices and operating and systems. So I'm going to jump ahead to puzzle 8 in our 15 puzzle progression, and we changed tack a little bit. Instead of just telling BB-8 where to go, we're now going to give the player the chance to actually control the character themselves. And so we see here, we actually have some event-driven programming. We're going to set up some events for steering up, down, left, and right, and then we'll run the game, and then the student actually is the person who steers R2-D2 to complete the mission. So all of a sudden they've gone, you know, within a few levels, within a little while in their classroom, they've gone to actually starting to build something that feels a little bit like a game. And what we do then is we start introducing more and more events and actions so the student starts realizing that they can layer in additional gameplay mechanics and start really thinking in this programmatic way. I will show one more level, which is puzzle 10 out of the 15. And here we start getting into these more gameplay mechanics. In this case, I have to read the instructions and be careful what we're doing. We're going to add points when R2-D2 gets a Rebel pilot and remove points when he gets a Stormtrooper. So here you see we have a few events and a few commands. Not a ton still, our palette is relatively small, but we're starting to construct these events. And this is where I was thinking about it as I recorded this to make sure I got it right. And now, just because we have events doesn't mean we've finished yet. We actually have to win the level. And so now we try and play, and you'll see we actually have to dodge some Stormtroopers and grab a Rebel pilot and not get touched by them, race over here. Now, interestingly, this is a bit tricky, but in our instructions, we actually give a hint to the user that maybe you can cheat a little bit. Maybe you can use this other creature, the Minoc, to actually give yourself a whole ton of points without having to worry about avoiding Stormtroopers. And some people might think that's a bit weird. Why are you encouraging cheating or hacking? But for us, once students start seeing these shortcuts and these tricks, it means they're really understanding the flexibility of code and the things they can do. And so we actually really love it when students have these aha moments where they're doing something a little tricky that's a bit outside of this very linear progression. Coming back to the work behind the scenes. So what did it take to build this tutorial? You can see one of many, many sprite sheets that we were provided by our partners at Lucasfilm as we had to build a walking, turning C-3PO. Assets. So we had art assets coming through from our partners. We had audio assets. We had something like 50 different drops of assets that we had to incorporate. There was a lot of iteration as we built animations and put them all together. So just having a tutorial that's somewhat rich like this with a whole bunch of art and animation, it's a lot of work in itself to deal with that workflow. We have another feature on code.org called PlayLab, which is a very similar sandbox for building games, and we were using the same core engine. So while we added a ton of new features for this tutorial, we also had to make sure that our original PlayLab kept on working. So there was a lot of core engine work that we were doing as well. We had to focus on this level progression. And you've seen we have a final 15-step progression. In reality, we did a ton of work on adjusting that level progression. And when we found levels were too difficult, we had to dial them back. Sometimes we had to make things easier. Sometimes we had to swap level orders to make more sense. We spent a lot of time just iterating on this level progression to help it really be a nice, smooth level progression for students. And iteration. We didn't do a waterfall model where we designed everything up front and then shipped it. We really, as we learned, we kept adjusting what we were doing. How did we land something like this? Well, we did a ton of classroom testing, and the classroom tests were invaluable. We would go to a classroom, we would have a few observers spread out around the room and just watch kids as they played through and take notes. And it was really good to have a few observers because we all picked up on different tidbits of information. And we'd come back, collect all our notes, and really readjust the entire progression. We use analytics. We can actually look at pass rates through every level so we can work out which levels are the difficult ones to get through. We have something called a funometer, and literally at the end of a level, we ask some students, did you have fun or not on this level? And we just look at the results, and we can actually work out of all our tutorials where each one sits in terms of fun with students. And again, iteration, but of course, when you have to ship something to millions of students who are all going to use it within a week, you have to make sure that you iterate smaller at the end, and so you can actually deliver something. Well, did we land successfully? Hard to tell, but I think we're pretty happy with what we turned out with. I made this this crazy slide just showing a few things that students actually learnt from doing this tutorial. Firstly, in the top left, they actually got to type in JavaScript and flip it back and forth between blocks. This is something we're adding to our curriculum for older students, but this is the first tutorial for Hour of Code where we actually ship this feature. Next, students learned that you can go get a Rebel pilot and make Stormtroopers appear. So we taught this kind of chaining creation technique, and you'll see how kids use that a little bit more in a second. We showed kids that they could build little games where you could win. You could set up goals and then you could have your character win the game. And the final slide, it's a little crazy. This looks like something might have gone wrong, but in fact, Kids so often told us, hey, I hacked your tutorial, look what I did. And we thought this was wonderful. We put no limits in so we could let them really go crazy. Because kids, when they got to this point, it means they'd understood this idea of touching characters to create new ones, chaining these things into getting an exponential growth in number of characters. So within an hour, these kids who had never coded before actually had got some pretty sophisticated concepts under their belt. And they could take this and share it with their parents and show them what they'd done at school that day. So we were really happy with this. Now, Hour of Code is a campaign that we do. I want to talk briefly about how this aligns with the goals of that campaign. The goals of Hour of Code are just to give students a taste of coding, to have very diverse appeal. Not just for students, we want to make sure that parents and teachers realize that this is a great experience as well. So often teachers have said, well, I remember you did Hour of Code and it went really well, and so now I'm more confident about teaching the rest of your curriculum. Because of course we have real curriculum, and this is just a gateway into students getting a much deeper, more thorough experience of learning computer science. Thank you very much. You are able to play the tutorial at code.org/Star Wars. Everything we do is open source, so you can jump onto GitHub and peruse our entire source tree. And I'm Brendan. Say hi if you'd like a sticker from code.org, and thank you very much.